These are notes from section 4.5. This is day 2. We are covering integration by substitution again, but this time we're doing definite integrals that have these bounds. So here we are asked to integrate from 0 to pi over 2 of cosine 2x over 3 dx. We're going to make u equal to 2x over 3, which is the same thing as 2/3 x. So my du would be 2/3 dx. So I need 2/3 dx, so I need to multiply by 2/3 so that I have 2/3 dx right there. If I multiply by 2/3, I also need to multiply by 3/2. And now I can rewrite in terms of u. So I have 3/2 times the integral of cosine u du. This is now something we know how to integrate. Before we do that, we need to have our bounds. The problem is 0 and pi over 2, those are x values. And this integral over here is written in terms of u. So I need to change these x values to u values. And we do that by plugging them into this u equals equation. So if I plug 0 in right there, I get 0 divided by 3, which is 0. So an x value of 0 matches up with a u value of 0. And plugging in pi over 2, I get pi over 2 times 2, that's pi, divided by 3. So an x value of pi over 2 matches up with a u value of pi over 3. And now we can ignore all of this. Just treat it as though this is the original problem. With indefinite integrals, we had to change back to x. We don't need to change back to x at any point here. So we're going to integrate cosine u. The integral of cosine u is sine u. Just going to bring my 3/2 down. And we are integrating from 0 to pi over 3. Again, I'm not substituting back in for x. If I do, I'm going to have to change these back to x values. Plug in pi over 3. Sine of pi over 3 is root 3 over 2. Plug in 0. Sine of 0 is 0. Subtract them. And multiply by 3/2. Answer is 3 root 3 over 4. So we're going to change the u the same way we did before. We need to change our bounds. We do that by plugging the values in for x and getting u values. And then we treat this as though it's the original problem and just integrate. Let's try another one here. Example 2 asks us to integrate from 1 to 9 of 1 over root x times the quantity 1 plus root x squared dx. So we are going to u substitute. We're going to make u equal to 1 plus root x, which is the same thing as 1 plus x to the 1/2. My du, therefore, is 1/2 x to the negative 1/2. This square root is on the bottom. That's the same thing as x to the negative 1/2. So there's x to the negative 1/2. There's dx. I need to multiply times 1/2 to make my du. 1/2 x to the negative 1/2 dx. There's du. I multiplied by 1/2, so I'm going to also have to multiply by 2. So I've got 1 over u squared. I'm going to write that as u to the negative 2nd. And everything that's circled becomes du. Again, I do need to change my bounds. I do that by plugging in for x. So here I have 1 plus 1. And plugging in 9 gives me 1 plus 3. And then again, we can disregard all of this. We don't need to worry about any of that. Once we've changed everything to u's, we're just treating it as though this is the original problem. So integrate. So I get negative 2 over u, evaluated from 2 to 4. Plug in 4. Plug in 2. subtract. So I get negative 1/2 plus 1, which is 1/2. Let's do one more here. Let's do this one. It asks us to integrate from -8 to 0 of 1 over the square root of 1 minus x dx. So u is going to be 1 minus x. My du is -1 dx. So I need to multiply by -1. Multiplying by another -1 out front would cancel those out. -1 dx, there's du. Got a negative sign out front. I've got 1 over root u, or u to the -1/2. Change your bounds to u values. I'm plugging them in right here. So I get 1 minus -8. Plugging in 0 gives me 1 minus 0. Notice when I changed the bounds this time, now the bigger number's on the bottom. You can either work with it as is, plug the top one in, the bottom one in, subtract and go from there. Or I'm going to switch them. I'm going to move it so the bigger one's on top, which I'm allowed to do as long as I multiply by -1. So it's already negative. That's going to change it to positive. And now we integrate. I get 2u to the 1/2 when I integrate. Plug in 9, square root of 9 is 3. Plug in 1, square root of 1 is 1. Subtract. Gives me 2 times that 2 that's already out there. Gives me 4.